Today let's talk about how to find the derivative of this function at x equals 0. As we can see, we have f of x is equal to e to the negative 1 over x squared if x is not equal to 0. And if x is equal to 0, we get 0. We want to find the derivative, and we have learned all the derivative rules. Maybe we can just do the chain rule here. Let's give it a try. F prime of x, e to the something, first that repeats, and then I have to use the chain rule. The derivative of that is the same as taking the derivative of negative x to the negative 2 power. Okay, and then put the power to the front, minus 1. Negative times negative, we get positive 2, and then x to the negative 3. So we multiply by that. And that should do it. And perhaps I can rewrite it. We have 2 on the top, and maybe let me keep this on the top as well. And then we'll put only this on the bottom. I could also have put this on the bottom, but anyways. Now let's plug in 0 into the x. Can we do that? No, because we'll be dividing by 0 in the exponent here, and another no, because we have a 0 here either. So what do we do though? So as you can see, if you just do the rule, it's not going to work. And in addition, how about this thing though? What did we do with this? It seems that we didn't use it. So could I have just replaced the 0 with, let's say, 2 or 17? I don't know. Well, here's the point. Sometimes if the derivative rule does not work, maybe we have to go back to the fundamental, and that is the definition of the derivative. Okay, so let me write that down right here. F prime of 0. And there are two versions for us to use. One is when x is approaching this number, or the other one is h approaching 0. I personally like to use x approaching whatever this number is, so x approaching 0. And the definition is f of x minus f of 0 over x minus 0, just like this. Now, check this out. Firstly, we have the limit as x approaching 0. This right here, minus f of 0. When x is 0, the function gives us 0. So this thing here is minus 0. Good. What do we put for f of x though? Here, remember, when x is approaching 0, we don't want x to be exactly equal to 0. So when x is not exactly equal to 0, the function is this. I will put down e to the negative 1 over x squared. And then the bottom is just x minus 0, which is x. Doesn't matter. For now, let me just write this down. And of course, the minus 0 doesn't matter. So we are going to look at this limit. And now if we plug in 0 into all the x's, the bottom will give us 0. And the top right here is negative 1 over 0 squared, which is negative infinity when we do limit. E to the negative infinity is 0. So this is a 0 for 0 situation. That means we're supposed to be able to use the L'Hopital's rule. But don't do it, because if you differentiate the bottom, you get 1. If you differentiate the top, as we saw earlier, we get this times 2 over x cubed. That expression, I think it's harder than this one right here, so no. Alright, I'm stuck, so what exactly do we do? Now, if sometimes these things don't work, maybe do a change of variable. That will actually work out really well. Here's the deal. I'm actually going to consider two cases. The first one is the limit as x approaching 0 plus, and because there's no plus or minus, we have to consider two cases. So let's look at this one right here first. And what we are going to do is, we'll do a change of variable. Let's say t equal 1 over x. And as you can see, that means, okay, let's just keep it like this. We get the limit as x approaching 0 plus, 1 over 0 plus will give us infinity. And then you will see that we have 1 over x, which is the t right here. And then this is going to be e to the negative, and then we have 1 over x squared. if you square both sides, that's just t squared, right? So t squared is equal to 1 over x squared. Yeah. So now this is actually better, because if I bring this down to the bottom, we get the limit as t going to infinity. The top is t, the bottom is e to the t squared. We get infinity over infinity situation. I will do L'Hopital's rule here. d dt, d dt. So we will get, the top is just going to be 1, and the bottom we get e to the t squared, and then use the chain rule here, we have to multiply by 2t. Now, as t goes to infinity, on the top is just 1, on the bottom is infinity, so we get to draw a conclusion, and we see this portion right here will give us 0. So that's good. And now, for the other direction, I will just put down similarly. Pretty much the same thing, and you can work that out on your own. When you have x approaching 0 minus, be careful with the negative and all that stuff, but you will also end up this being equal to 0 as well. So all in all, we can come back here and say that this limit is equal to 0. So that means our derivative here is just equal to 0. So this right here is a correct solution for this question, but I'm not sure how I feel about this question though, because I can think about so many wrong ways of doing this and then get the correct answer, because the answer is just simply 0. For example, somebody could just differentiate the first piece, which is 2e negative 1 over x squared over x cubed, and then rewrite if x is not equal to 0, and they can differentiate 0, which is 0, and then maintain if x is equal to 0. And we want f prime of 0, so they say, by looking at this, we should be done. No, not correct. Not correct. Because the danger part is, if you have this function, let's say we change the 0 to, let's say, 5 or 17. You guys know I like the number 17. If you differentiate 17, you get 0, so this right here is still true. And is the answer still 0 though? Not anymore. The reason is because if you change this to 17, the truth is this function here is no longer continuous at x equals 0. If the function is not continuous, you are not going to have derivative at all. So the derivative will have been d and e does not exist. So be really careful. Yeah, that's it. And let me just change back the 17 to 0.